All right, so this is setting up for the geometric test and divergence theorem. So these are two different methods telling whether a series diverges or converges. Both are fairly simple and can kind of be used in similar situations. But once again, it's just two different methods. So we'll go over setting them up, using them, all that good stuff. So starting with divergence theorem or nth term test, either name is acceptable. This one's very straightforward. If the limit as n approaches infinity of the series does not equal 0, then the series diverges. So basically what this is saying is that if the last term of the series does not equal 0, then the series has to diverge. So if that's the case, and you take the limit of the series as n goes to infinity, and it equals some non-zero value or infinity, then you're just going to say that the series diverges due to divergence theorem or a term test. Once again, both are acceptable. And that's the easiest way. This is the easiest way to tell if a series diverges. This test can't tell you if a series converges. It can only say that a series diverges. So next we have geometric test. This you're going to want to use if you can't obviously use divergence theorem. So you're going to skip straight to this one if that's the case. So first, you're going to write out a couple of terms. This step is optional. I find it very helpful. It kind of helps you visualize the series. So then you're going to use those to find the common ratio. So this is the common ratio is what you're multiplying by each time to get the next term. So you're going to use that R value to evaluate the series. So if the absolute value of your common ratio is greater than or equal to 1, then the series diverges. And if that's the case, you're just going to say series diverges by geometric test. However, if your common ratio, absolute value of your common ratio is less than 1, then your series converges. And if your series converges, then you have to find the sum using the sum formula, which is the first term over 1 minus your common ratio. It's shown down there. So this is actually the only test that you'll learn this year that can give you a value for the sum of the series. So not only do you have to write series converges by geometric test, but you also have to show the sum value. And that's pretty much it. This is a little about me. Very cool.